So in a recent video, I talked about ER diagrams and I kind of talked about the schemas that I'm using to build out this IDEA video suggestions application. And I want to kind of walk you through how certain types of things work, like inner joins, left joins, so that we can actually grab all the ideas manually and truly understand how to write SQL queries. I think it's something that's important if you're dealing with Postgres. How do you write SQL queries? You might be using an ORM like Drizzle or Prisma. And those kind of abstract SQL away from you, but at some point you're going to have to learn the SQL. So I think it's good to practice how do you actually get this data back from your database in an efficient way. All right, so what do I want to talk about? I want to talk about how do I fetch back all the ideas for a particular user. And then we're going to go ahead and also get their upvotes and try to get the tags that they have. I'm going to go to Table Plus, and we're already connected to my local database. So the first thing I want to show you is that we have all of these tables, right? The important ones for this video would be the user table, because a user can upload ideas, and then an idea can have upvotes, and then an idea can be tagged by things. So if you wanted to get all of the ideas by a certain user, how would you do that? I think we're going to go ahead and just walk through some simple examples of SQL, and then it's going to get a little bit more complicated. So pay attention if you want to learn a little bit more about SQL. So in this user table, we have some fake C data, but one of the things I want to do is try to show you how you can select a user based on an ID, right? This is the most simple type of query, but it's very important to learn when you're trying to learn SQL. So let's grab one from like Casey Jones. We're going to copy this ID, and then I'm going to load up my SQL editor over here. I'm going to say select star from, and then we're going to say public dot user where ID is equal to, and then we can paste in that user ID. And notice that when we run this query with a command enter, we get back that record. Okay, so this is how you can fetch data from a database using SQL. You can basically change the table name. So public is our schema, and then user is the table. And then these columns, you can basically do a query on. Now, I'd be careful if you have a lot of data, you should not have a where clause that's looking for something that's not indexed. It's going to be very expensive. But if you just do like a one-off query, it should run fast. But if you want to have this run in your actual application code, you want to make sure you have indexes on whatever you're trying to query for. So for example, let's say we actually wanted to get the name, which happens to have the word Jones in it, right? So I can actually switch this to name, and then we can say like, and then I'm going to say Jones. Run that, and we should still get back. I actually need to add a percentage there, I believe, and that's going to kind of be like a wild card, right? So I want anything that can be prefixed with whatever, but I need it to end with Jones. We could do the same thing with Casey and just end that with a percentage, and that's going to give back Casey Jones. What other names do I have in this table? I think there's one called Alex. Yeah, so we have Alex Smith. Yeah, so that's kind of how you can do that. You can also ignore case. So like if, for example, if I want to find Alex Smith either with a capital A or lowercase a, you can say I like. There's a bunch of different keywords you can use for like comparisons. So kind of read through Postgres and learn how those work. But that's the gist of how do you select a record from a table using a where clause. So let's take this a step further. I want to figure out how do I select all the ideas from my database. So we're going to change this query up a little bit. So I'm going to say select star from idea. And notice we get back a bunch of rows. It's basically going to give us every idea that's in our database. Let's say you didn't want this many. You could actually say limit. I could say like 10, or I could say like 2. Okay, and that'll limit how many comes back from Postgres. If you have a ton of data, you should probably remember to always put your limit here, or else whatever database editor you're using could freeze up if you're fetching back a ton of data. But this is good if you just want to kind of like peek through and understand how the data kind of looks. So we have all these ideas that are in our system, but if we wanted to display them on a page like this, we have to join with some other columns to be able to get the upvotes. Also to get the tags, which is a little bit more complicated, but we're going to start with the upvotes. Okay, so we have a upvote table here, and this is how we basically link an idea to if it's been upvoted by a user or not. Okay, if you go back to the ER diagram I talked about, we have an idea, and then you can have an upvote record that exists if someone liked it. Let's try to write a query to get back all the ideas with their upvotes. So I'm going to say select star from idea, and then I'm going to say left join, and then we're going to join on upvote on idea.id equals to upvote.idea ID. Okay, so what this is going to do, I'm actually going to limit by 1 so I can show you. When I run this, we're going to get back a lot more data now. We're going to get back all the data that's associated with that idea table. But then on the right, you'll see that we also get the data that was associated with the upvote. Now, in this case, this idea was not upvoted. But if you do enough searches, you'll probably get one that does have an upvote. Okay, so let's go ahead. Okay, here are some. Now, if you wanted to make this easier, I could say where upvote ID is not null. Okay, and that's going to give us back all of the things, the ideas that actually have upvotes. So this is a nice little query you can tack on as well. But the issue with the left join is that you're going to get back a bunch of duplicate records, right? So you might have multiple ideas that were upvoted multiple times by different users. And I don't think we'll see, yeah, so here's an example. We have two that have the exact same ID. These two records, they're the same idea, but they've been upvoted by different user IDs. So this is where you can bring in like a aggregate function, like a count, which will also require you to learn about groupings. So we're going to say select, we're going to say title. Actually, I'm going to say idea ID. We'll say idea.title. And we're also going to say count. And then we want to count how many, like for example, probably counting this. You see how this has two records? That means it has two upvotes. So I can just go ahead and count the idea IDs here. And then if I were to run this, we should get back, in fact, I'm going to say as total votes. We can actually alias this with an as. And as you're typing this out, you should probably put this on new lines. Okay, actually, I can zoom in the text to make it a little bit bigger, so hopefully this helps. I'm not redoing the video, so hopefully you are staying with me. So we're going to run this code, and now we're just going to get an error because we didn't do a group by. Whenever you have like an aggregate, I think these are called aggregate functions. Yep, that's what they're called. You need to have a group by. So we're going to say group by, and then again, we're going to group by the idea.id. So I'm going to run this. And now if you scroll through here, we're going to get these two. Remember, there were like two rows that all represented the same idea ID. Now we have the counts here. So we know how many upvotes were added to these rows. So at this point, we've hit on a bunch of different topics. We've hit on how do you select certain things from a database. Notice that we removed the star and we're actually putting by hand what we want back. The star is problematic because it's fetching tons of data from your database. Typically, you just want to fetch back the bare minimum if you can, but you're not sending so much from your database to your web server and then from your web server to your users. You can do an alias like this. So you can alias certain rows as whatever column names that you want in your results. We learned about left joins. We learned about limits, some group bys. Typically, it doesn't matter if you do like uppercase or lowercase in Postgres. I don't think so. So I like to just make it uppercase so it's easier for me to read. Now, in terms of the left join, how that kind of works, I don't know if I really kind of explained it, but we're taking two tables. We're taking the idea table and the upvote table, and we're telling it which columns from each table it should kind of like cross-reference. And if there's a match between those columns, that's when you get those like multiple rows next to each other with the same ID. There's also inner join. I think there's also an outer join. You should probably learn those at some point. We're not going to cover those in this video. We're going to stick with left join because typically it's really good for getting like an aggregate or a count of how many things were associated with that. So the next thing I want to do is I want to try to also get the tags. So notice in our ER diagram, we have this ability to tag ideas, and that's happening through a junction table or a join table in the middle. Again, all these tags here, these are unique in our database. If you go to tag, you'll see that we have all these unique tags. And we also have idea tag, which is our join table that links an idea to a tag. So we got to figure out how do we join with these various things so that I can show which tags are attached to this idea, right? So that we can show it in the UI. This is where it gets a little bit tricky, but we're going to go ahead and restructure this a little bit. I'm going to add another left join. I'm going to say left join idea tag on idea.id equals to idea tag dot idea ID. Oh, it's called idea. Sorry, it's idea ID. So let's run this now, and we should get back again. The grouping by is going to mess this up a little bit. Let me limit one, and I'm actually going to get rid of the count in the group by just for now. But we can add this back in. So I'm just going to put this up here, comment it out, and we're going to focus on just understanding what we're doing right here. So, okay, so we added this to join our idea table with that join table. But now we also need to left join on the tag. And then we're going to actually join the tag with the idea tag over here. Technically, I think you could also do like an inner join here if you wanted to, and I could say idea tag dot tag ID equals to tag.id. Okay, let's just try to run this. And we should get back, if I were to actually fetch the tag name, notice that we get back a tag of education. But remember, I'm going to go ahead and limit 5. We're going to get back a bunch of rows for every tag, because you can have like 7 or 8 tags on every idea. So what I'm going to do is I want to combine all these together. Like I want to have all these tags just live in a single row. All right, so I'm actually going to add the group by back. We're going to say array agg, so that's an array aggregate, and then we can simply say tag.name. If I run this, notice that we get back all of the tags that are associated with this idea, and that's put in our result set. And because we're grouping, it basically, collapses all of those rows into one, and we can kind of send that back to the user. So notice here that these results are not like in like a JSON format. So one thing we can do, we can actually say JSON B aggregate and run that, and notice that we get back an array of things. So when we get this data back in Node, we can just parse it as a string, and then we'll actually get like an array of keys that we can use, which is pretty nice. But sometimes you actually want to get back an object, so like an array of objects. So we could probably actually go here, and then we could say JSON build object, and then we're going to say name. Make sure we close that. But then we also want the ID. So I'm going to go ahead and just say ID, and I'll say tag.id. And I think this should build up that array that has every tag with that unique tag identifier in it. So like this is basically what it's going to look like. Okay. So then like when someone were to click on a tag, you can actually use the ID instead of the name in your UI to further do queries or filters. Okay, so I think this was a pretty good overview of a lot of stuff. If you're a beginner with Postgres, I'm sure most of this was over your head. But if you're like intermediate, maybe you learned something new by watching this. I think I might make another video to cover like the difference between left joins, outer joins, inner joins. Those are very important as well when you're dealing with Postgres and SQL. Yeah, hopefully you enjoyed watching this video. If you did, give it a thumbs up. Other than that, have a good day and happy coding.